Hello, students. Welcome to today's lecture. We are going to be looking at oxidizing and reducing agents. That will be our topic for today. Okay. And what is oxidizing agents? What is oxidizing agents? What is oxidizing agents? Oxidizing agents are electron acceptors. Okay. That is substance that gains an electron from other substance and themselves becomes a reduced species. Any chemical substance that can gain electron from other substance and at that time and at that point reduce itself is an oxidizing what? Agent. Okay, I'll give an example. Supposing we have sodium atom plus chlorine atom. The number of atoms share electron here is 1. Let me use dots to represent the number of valence electron of sodium, and then 7 at the atom shell of chlorine. This is 7 now. Okay, which of these two will lose an electron? Sodium. So it means that electrons are being transferred from sodium towards chlorine. Okay, looking at this critically, number of electrons of this sodium is 11. Proton is also what? 11. Do your plus and minus. It's 0, isn't it? Number of electron here is 17. Proton is also what? 17. Your plus or minus is what? 0. Now let's see the product of the reaction. Now that this has lost electron to this, okay? Now number of electron for sodium is no longer 11, but what? 10. That one I've gone here. And then here we have proton is what? 11. So do your plus and minus. What do you have here? Plus 1. So here we have sodium ion now. Are you with me? Plus what? Cl. Let's see. It has gained electrons. So here is what? 18. So proton is what? 17. Altogether minus 1. So here will be minus. So look at this chemical reaction. Can someone tell me which one is the oxidizing agent here? Which one is the oxidizing agent? Oxidizing agent is chlorine. You know what I told you? The one that gain electron. The one that what? Gain electron. In fact, they are electron what? Electron acceptors. In fact, what do I say? They are electron acceptors. They gain electron from other substance. And at that point, they are reduced. Now, it gains electron and now appears to have more electron than proton. That's why it's negatively what? Charged. Where its oxidation number has now changed from what? 0 to what? Minus 1. It means that an oxidizing agent, becomes the one that we what? Reduce. And then in this reaction, sodium is the what? Reducing what? Agent. Why? Sodium is the electron what? Donor. Reducing agent are electron donor. They donate electron to another what? Substance, or they lose electron to another substance, and then themselves becomes what? Oxidized. At this point, having lost this electron, it will now appear to have more proton than electron. So when you do your plus and minus here, you have that the total nuclear charge is what? Plus 1. So there is a change of states from 0 to what? Plus 1. It means that sodium in this case becomes the what? Oxidized what? Species. A reducing agent is oxidized species, while oxidizing agent is the reduced what? Species. Are you with me? Okay, now quickly, let's also look at this scenario. Supposing whatever I have something like CuO, it's copper 2 oxide plus H2, and then I have H2O plus Cu. In this reaction, Which one is the oxidizing agent and reducing agent? The oxidizing agent, what to do in this case? Not copper, it's copper 2 oxide. So what you do in this case is to assign oxidation to every species in this reaction. Give this -2, this +2, this 0, this +1, this -2, this 0. And now go to your reactant. Okay, so the question is, which one is the oxidizing agent? Between CuO and hydrogen, which of these has reduced in the reaction? It is copper. Copper has reduced from +2 to 0. According to our definition, 1 minute. According to our definition, oxidizing agents will be a reduced species. Now you see that it has changed from +2 to what? 0. Are you with me? Now, reducing agent is hydrogen. Why? It is the oxidized species. It has changed from 0 to what? +1. Yes. So the reaction here, copper 2 oxide is what? Sorry, oxidizing what? Agents. While hydrogen is what? Reducing what? Agents. Okay. Maybe I'll give one more example for you to think of it. Look at this. I have now in the reaction, ammonia NH3 is acting as dash. Okay, yes. Ammonia is acting as. I've always said this. Try to assign oxidation states. Okay, there are some you have to know. Even if this answer is going to be kind of a problem to you, what you will do is the set rule. The set rule for hydrogen, you know, is +1. So check it. Here is what? -3. Are you me now? As a summing up of everything here. This is 0 because it's in elemental states, uncombined states. This is also what? 0. This is +1, -1. So this will give you a kind of background to what is this man doing in the reaction. Check. Hydrogen is not changing in the reaction, so neglect it. Nitrogen changes because here it is -3. Here is what? 0. Ask yourself this question. Ammonia in nitrogen, or nitrogen in ammonia, is the oxidation states decreasing or increasing? Is increasing, Abby. So that means it is the oxidized species. So because it is the oxidized species, NH3 in its reaction is acting as what? Reducing what? Agent. And then, of course, this should be acting as what? Oxidizing what? Agent. Are you with me now? A redox reaction is one in which oxidation occurs in the same reaction. This reaction is redox reaction. A redox reaction in the sense that you can see that this nitrogen here oxidized, this chlorine here reduced. So this is a redox reaction. And you must take notes. In redox reaction, electron must be transferred from a reducing agent to oxidizing agents. I say, which one transfers the electron here between this and this? Which one is transferring electron? Ammonia. Which one is getting electron here? Chlorine. That is from the definition. We define, in fact, the clear definition of reduction is that they are electron donor. Why oxidizing agents are what? Electron acceptors. That's very simple. That's very basic. So with this, you now know that electrons are being passed or transferred from what? From what? Reducing to what? Oxidizing. I'll give you an example. Ion 2. Are you now? Ion 2 can lose electron to form what? ion 3. Are you with me now? Then chlorine can gain electron from ion 2 to form what? Chloride what? Ion. This is a two equation. One can call this equation 1 and this equation what? 2. But there's something to this equation that I want us to understand here. In redox reaction like this is a typical redox reaction as well as ionic equation. In this kind of reaction, you will notice that the number of atoms here appears to be balanced. You know what I mean now? How many moles of Fe do you have here? Just one. How many here? One. But in terms of total net charge here is +2, but here is +3. So it means that the equation is not balanced ionically. So what must we do to balance this reaction? We're going to add electron, even though there is no free electron. In ordinary condition, no free what? Electron. We're just adding it because it is not, you are adding the electron theoretically, not in practical sense, there is no free electron. So this electron I'm adding here is just theoretical. How many electrons am I going to add to reconcile the charge here? Just one. This one is just -1 because this one is, so here's -1. So -1 plus 3 should be what? +2. So both sides are atomically balanced. Okay, now there's a problem to this equation here. There's a problem here. What's the problem? Uncombined chlorine does not exist. Bear it in mind. So it's diatomic. So you're having it as Cl2. Okay, that means you must balance this atomically because before you start thinking of balancing ionically. So the number of atoms must be balanced first. Are you with me now? It must be balanced. And now that it is balanced, what do? Balance the charge. Total net charge here is 0. Yes, -1 times 2, -2. So what are we going to do to balance this reaction? Theoretically, you add electron. To which side? This side, I mean, 2e what? Minus. Okay, just like I said, there's no free electrons. So we're going to deal with these electrons. Since there's no free electrons, we deal with it. What must we do to deal with it? The electrons lost here must be equal to electron gain. So what do? Most often we multiply the two equations by this electron. So what I'm going to do is to bring this electron here, multiply everything in this reaction, and then this one electron here, multiply everything here. So this 2 times this have what? 2 what? Fe 2 plus. What do you have here? 2 Fe 3 plus 2e minus. 1 here, 2e minus plus what? Cl2 here, 2Cl minus. Since there's no free electron, what do? This cancels out. And then the overall reaction will be, you look like this. 2Fe 2 plus Cl2 and then 2Fe 3 plus 2Cl what? Minus. As electron cancel out, the overall reaction is written as this. You can only have this the moment the electrons cancel out. And this reaction must also make sure that the number of atoms appears to be equal to that of atoms at the product side. Have 2 moles, have 2 moles. You have 1 atom of chlorine molecule, 2, but reconciling atoms are balanced here. Charges, total charge here is +4. This is 6 minus 2 is still what? 4. So it appears that the equation is balanced. In the reaction, one may ask you to state which of the reactants, which one is acting as the oxidizing agent in the reaction. Yes, chlorine. You don't need to start thinking to see how electron. I told you there is no free electrons, even though there's no one that will give somebody electron free. But just this is what we say in chemistry to make things look real. It's not real. So the only thing to know that there has been a kind of a case where there is oxidizing ability and the reducing ability is in the change of their states. The state of chlorine is reducing. It is -1. Here is 0. So with this, one should know that in this reaction, chlorine is the what? Oxidizing agent. The reason is because its oxidation number has changed from 0 to what? minus 1 is the reason. Are you with me? Okay. Okay. So I think I'll give one question to see how we are going to see if the equation will be balanced atomically and before considering balancing ionically. Please try this quickly. I have a reaction. Once you balance, check, try to deduce which one is oxidizing agent and which one is reducing agent. Copper 2 plus aluminium. This one is aqueous states. This one is solid. And copper solid plus aluminium aqueous. Let's check if the equation is balanced, and if it's not balanced, try to balance it. Without wasting time, we're breaking up, and then wasting time coupling out. I think the best method of balancing this is to exchange the ions. Copper has 2, aluminum has 3. Exchange it. So it means that since copper has 2, place this 3 here. Are you with me? Since aluminium has 3 and copper is with 2 charge, IB, exchange it. 2 go here. Anywhere you see aluminium, put 2 to it. Anywhere you see carbon, put 3. Anywhere you see copper, put 3. So this 3 is from aluminium. This 2 is from what? Copper. So here it will be 2. Here will be 2. This equation is balanced. Check it. 3 copper, 3 moles of copper both sides, 2 moles of aluminium, 2 moles of aluminium. In terms of charge, 2 times 3 is 6. 2 times 3 is 6. It's balanced. Or you can follow the process of balancing. Okay, Al 3 plus. So what do you do to balance this half cell? Add 3E minus. Copper here to copper here. What do you do to balance this one? Add 2E here. So what do you do? You multiply here by what? 2. Here by what? 3. So here is 2Al 3 plus 6E minus. Here 6E minus plus 3Cu 2 plus, and here 3Cu. No free electrons, so you cancel. Then the overall now will be what? 2Al plus 3Cu 2 plus equals to 2Al 3 plus 3Cu. Then come back to this. Are you with me? So which one is behaving as oxidizing agent in the reaction? The oxidizing agent in the reaction? Copper. Why copper? Plus 2 reduced. Then aluminium is the what? Reducing agent. Why? 0 plus 3 oxidized. They may ask you in the exam, electron flow from where to where? Electron flows from aluminium to what? Copper, because aluminium is the electron what? Donor in the reaction, being a reducing what? Agent. Does it follow?